All right, this is Precalculus, section 2.2, the graph of a function. So when we collect data about, say, gasoline, how do we handle this data? Is there a relationship, and how can we use that relationship to give us more data and more information? One of the ways is to make a scatter plot and identify trends. All right, so our first and only learning objective is to identify the graph of a function. All right, the vertical line test. So the vertical line test tells you if your graph is a function. So any points of your function on your graph is a function if and only if every vertical line intersects the graph in at most one point. Make sure you guys include the picture to go along with the definition. Okay, so which of the following are graphs of a function? So if you get out your vertical line, and we'll use and drag it across, you can see that A is a graph of a function. So if I get out my vertical line and I drag it across my cubic function, I can see that B is also a function. So go ahead and make sure you write that down. Y equals x squared, just draw a sketch of this graph and put a function, and then put y equals x cubed. Draw a little sketch of the graph. You guys don't have to do grid marks, just a nice sketch is okay. And it's good practice because it reminds you of what a cubic and a quadratic function look like. Both of these are functions. All right, and here they are. So go ahead and draw the sketch of a parabola that opens along the x-axis. And then draw the sketch of the circle.
I'd like the same color as this.
Okay. So you guys, both of those are not a function. Both of those are not
I'll just bring it back.
a function. Oh! Surprise! Surprise learning objective.
I don't like this surprise.
Obtain information
Surprises are exciting!
from or about the graph of a function. To get information from or about a function. Alright. So if I go ahead and sketch this graph on your paper, we might as well get used to some trigger functions now, so that when you see them, it's not scary crazy land. We're going to take a look at the graph and figure out what my function is when x is equal to 0, what my function is when f is equal to 3 pi over 2, and what my function is at 3 pi. All right, so if we look at our graph, find x equal to 0. And our y value is 4. So f of 0 is equal to 4. Then look at your graph and find 3 pi over 2, which is right here. And at 3 pi over 2, you are also at 0. And at 3 pi, so if this is pi, 2 pi, 3 pi, our value is negative 4. So f of 0 is 4, f of 3 pi over 2 is 0, and f of 3 pi is negative 4. So we look at B. If we're looking at domain, what values of x are we looking at in this graph? Well, we know the smallest value of x is 0, and the largest value of x is 4 pi. So x is a set of numbers from 0 to 4 pi. And you guys check out the way they bracket this. The brackets are really important. If you have a closed bracket, is what this is called. If you have a closed bracket, that means this value is included in your domain. And I'm pointing this out because you will get this wrong on your quiz if you don't use the correct brackets. If you have a parenthesis instead of a bracket, then that value is not included in your domain or your range. So in this case, 0 and and 4 pi are both included in our domain, so they get a bracket. Now the range goes from, so what's my smallest y value? Well, it's -4, and the largest y value is 4, and are those included or not included? Are -4 and +4 included in the range or not included? Included, yeah. They're included, so they're going to get a closed bracket. It just means the set of y's, so it's just a way to, so the set of all y values between -4 and 4. So it's y to indicate that you're talking about range, and then spitting out the range. All right, so let's list the intercepts. So we have the y-intercept at 0, 4, an x-intercept at pi over 2, 0, an x-intercept at 3 pi over 2, 0, x-intercept at 5 pi over 2, 0, and an x-intercept at 7 pi over 2, 0. Can we see a pattern in those intercepts? In the x-intercepts. That's why we spend so much time finding patterns in math. Okay, so if we look at the question, how often does the line y equal 2 intersect the graph? So let's go ahead and throw that line down, and we can see that it intersects 4 times. 1, 2, 3, 4. And then for what values of x does our function f of x equal -4? So at pi and 3 pi. By the way, mega easy, right? So all we're doing is looking at the graph and pulling off information. Nothing fancy. And then lastly but not leastly, for what values of x is f of x greater than 0? So you look, and if, I have to look at my screen because I can't see, because I can't align my board, because it's too far off my board to align. Okay, so actually let me escape it. I can't see it. What I wanted. Okay. There we go. So in interval notation, we include 0 because 0 is included in our graph to pi over 2. That is, but pi over 2 is not included because we are equal to 0 at pi over 2 and not greater than 0. Union with, the next time we are positive, it's at 3 pi over 2, all the way to 5 pi over 2, and neither of those are included because we are not greater than 0 at these two values. We are equal to 0. union with 7 pi over 2 to 4 pi. And 7 pi over 2 is not included because we are actually equal to 0 at 7 pi over 2. But 4 pi is included because we are equal to 4, which is greater than 0 at 4 pi. All right. Okay, so obtain information from the graph. So if we look at our function f of x equals x over x plus 1, our first question is the point 1 comma 1/2 on the graph of f? So we plug in 1 for x, and we get out 1/2, so we can say, yes. Si, senor. Our second question, if x is equal to 2, what is f of x? What point is on the graph of x? So we are going to plug in 2 to our function. F of 2 is equal to 2 over 2 plus 1, which is 2/3. So the point on the graph is 2 comma 2/3. So in this case, we're doing the opposite. We're just taking the function and identifying points on our graph. If f of x is equal to 2, what is x? What point is on the graph of x? A little bit more difficult because now we need to figure out the x value. So if f of x is equal to 2, what does x have to equal in order for x over x plus 1 to equal 2? So I'm going to multiply both sides by x plus 1. Distribute out the 2. Subtract 2x from both sides. And divide by -1. So x equals -2 will give us an output of 2. So the point on the graph is -2 comma 2. All right, so we're going to fuss with the average cost function, and it's actually a part of your practice assignment today, is the average cost function. The average cost C of manufacturing X computers per day is given by the function C of X equals 0.56 x squared minus 34.39x plus 1,212.57 plus 20,000 over x. We are going to determine the average cost of manufacturing 30 computers, 40 computers, 50 computers. We're going to graph the function for x values between 0 and 80. And then we're going to create a table with our calculator utility. And then find out which value of x minimizes the average cost. Because if you're manufacturing something, you want things to cost as little as possible so you can make as much money as possible. So for the first one, we plug in 30 for the x value. And go ahead and take a moment and do this on your calculator to make sure you can input numbers correctly and get the correct output. And then the second one we're going to put in 40, and the third one we're going to put in 50. Okay, so 30 computers is $1,351.54. 40 computers is $1,232.97. And 50 computers in a day is $1,293.07. So if we're going to graph that function, make sure in your graphing window it's between 0 and 80. It can't include 0 because what happens here, if 0 is included, it explodes. So it should be greater than 0 but less than 80. The x values. So if you're looking at your in your window, it should go from your x should go from 0 to 80, and I believe we're counting by tens. So your x scale is 10, and then on the y it's 0 to 4,000, counting by 500. All right, so there's the graph of the function, and here is our table.
So when we do we're really looking for.
So if we're using our table to find the minimum value, you just keep scrolling down until you hit that bottom where it's right around 41. Where you go, oh, this is $1,235, $1,233. This is $1,231, and then it starts going back up again at $1,232. So you know here is your minimum. You can also use the calculate the minimum function on your graphing utility, and that will tell you the minimum value as well. So the minimum is $1,231.70. That is the minimum average cost. All right, so to summarize, the graph of a function is a collection of points that satisfy y equals f of x, and the vertical line test is that you have a function if for every vertical line you can possibly draw, it only intersects your graph at one point.